In this video, I am discussing the basic differentiation rules. Hopefully, by the end of this video, you will be able to apply the differentiation rules to compute the derivative of algebraic functions. I will make a separate video on the application of different differentiation rules to compute the derivative of exponential function, logarithmic function, and trigonometric function. So let's start with the definition. Again, recall the definition of differentiation. It is a process. It is the process of finding the derivative of a function. Again, here are the different commonly used derivative symbols. We have y prime. If the function starts with y, you can use this y prime symbol to get the derivative. If your function starts with f of x, you can use f prime of x. If your function starts with y, you can also use this. This is the Leibniz notation. This one is the Lagrange notation. And also this notation is for general form or general notation to use to solve for derivative functions. If, for example, if you have g prime g of x, then you can solve for the derivative of g of x. So that's you can solve for the derivative of g of x with respect to x, right? Now, first rule of differentiation, it is called constant rule. If you have any constant number, any real number, including rational numbers like pi, Euler, those are also constant, then the derivative of those numbers, and even if you have negative numbers, zero number, and positive numbers, even if it's fraction, negative fraction, their derivatives are always zero. That's why it's called constant rule. So, for example, the derivative of positive 8 is 0, derivative of 0 is 0. The derivative of negative 5 is negative 5 is also 0. The derivative of a fraction number, 1/2, is also 0. The derivative of an irrational number, pi, that even if it's irrational, the decimal points is unending or infinite, that's still 0. Because pi is approximately 3.14, and that's still a constant. That's without a variable. So a number or a real number, its derivative is 0. So that's the constant rule. The derivative of constant is 0. Second rule, identity rule. Identity rule means if you have only one a variable with the highest exponent of 1, that its derivative is only 1. Okay? So the derivative of x raised to 1, or just simply the derivative of x, is just 1. Right? Remember that. Again, the constant rule, the derivative of any constant is 0. The derivative of x is 1. Next, the third rule, we have the power rule. The derivative of, if we have the function f of x in the form of f of x equals x raised to n, where your exponent, the n, representing n, is a rational number. The example of rational number is 1/2, the positive integer, the counting numbers, the 0, and the negative integers, -1, -2, -3, and so on, and also the fraction numbers, positive and negative fractions. Those are rational numbers. Then, if you want to get the derivative of x raised to n, you just need to multiply the exponent to the coefficient, which basically the coefficient of x is just 1. So n times 1 is just simply n, right? Then x, copy the x, then subtract 1 from the exponent. Right? So let's have an example. The derivative of x raised to 3 is just equal to, first multiply the exponent to the coefficient, which is 1 basically. Therefore 3 times 1 is just 3. Then copy the variable x, then subtract 1 from the exponent, 3. The n is 3 here, so subtract 1 from the 3. Therefore we have simplified 3x raised to 3 minus 1 becomes 2. Therefore the derivative of x cubed is just 3x squared. Okay? Another example, the derivative of x raised to -2. Again, just multiply the exponent to the numerical coefficient. The coefficient is 1 here. In algebra, if you don't see a number at the left side of x, that implies there's 1 there. So there, -2 times 1 is just -2. Then copy x, the variable, then subtract 1 from negative 2, the exponent. Simplify negative 2x. Negative 2 minus 1 becomes negative 3 because they have similar, or they have the same sign. You need to add them and copy the sign. So now the derivative of x raised to negative 2 is negative 2x raised to negative 3. Another example, the derivative of x raised to 8 is just simply 8 multiplied to 1 multiplied to the coefficient becomes 8. Copy the variable x, subtract 1 from 8, becomes 8x raised to 7. And that's the derivative of x raised to 8. Right? Now, another example. What if we have a fraction number, or we have a fraction form expression, the derivative of 1 over x squared? First, you need to rewrite you need to rewrite this 1 over x squared. Now recall in the property of exponent, if you have 1 if you have x raised to negative n, you just need to add numerator 1, then the denominator will be your original expression, but the exponent negative n will be positive, so x raised to n. So that's just how you make the exponent negative to positive. So instead of x raised to negative n, you will have 1 over x raised to n. Now in this form, this is from here. Now we will write it to here. Okay, so if it has the positive exponent, that means only the property of exponent, the reverse process of this one, from here to here. That means that there is a variable x. There is a variable x with an exponent of negative number 2. That's our n. Right? Then get the derivative of that. Okay, so the derivative of x raised to negative 2 is just simply multiply the exponent negative 2 to the coefficient 1. There's 1 there beside the x, variable x. So negative 2 times 1 becomes negative 2. Copy the variable, subtract 1 from the exponent. Then that becomes negative 2x raised to negative 3. If you want to rewrite in this way, this form, you can rewrite that negative 2. Then that this one has a negative exponent, so you can rewrite that into this one. Right, so you can write that as 1 over x raised to positive 3, or x cubed. Right? So now you can also rewrite that into this form. Negative 2 times 1 is just negative 2. So write negative 2. Then the denominator will be just your original denominator, x cubed. And you could have that as your final answer. Okay? That's just art of writing the final answer. But if your answer is just this, that's okay. They have the same value. If your answer is like this, just this, that's okay. They have the same value, right? So they are the same. Now next, what is the derivative of a square root of x? Now using property of exponent, when you have x raised to m over n, you just need to use square root, then write the variable x inside the radical symbol. Then itong n natin, the n will be here and here, then your m will be the exponent of the variable inside the radical symbol. So that will be your m here. Your m will be here. Right? So here you have the square root of x, so you can reverse the process from here to there. That means if you have the square root, there's 2 here. When you say square root from the square, there's 2 here, and the exponent is 1. So basically that is x raised to 1/2. Right? So the n is 2. There's 2 here, and the exponent of x here is 1. That's why it's x raised to 1/2. Then get the derivative of x raised to 1/2. Simply multiply the exponent to the coefficient 1. So 1/2 times 1 is just 1. 1/2 rather. 1/2 times 1 is 1/2. Then copy the variable, subtract 1 from the exponent 1/2. So when you subtract 1 from 1/2, that gives you negative 1/2. Right? So 1/2 x raised to negative 1/2. If you want to write that into radical form, then you can do that. 1/2. Then the radical form of this is um, square root of x raised to negative 1. You can also write that as 1 times this is square root of x raised to negative 1. So square root of x raised to negative 1 over 2. So you can have this as your final answer. Alright, let me just rewrite it down a little bit down. So 1/2 1 times the square root of x raised to negative 1 is just square root of x raised to negative 1, right? So x raised to negative 1 over 2. So you can have this as your final answer, right? Or if your answer is just this, then that's okay. If your answer is written this way, that's okay. They have the same value, right? Alright, now we have the last example here. Alright, hold on. Let me just erase this. Next example. Last example, we have the derivative of the fourth root of x raised to cube, or x raised to 3. You can also use this process. You can rewrite that. So if we write that into exponential form, that means we are getting the derivative of, this is the n, so that should be the n, that should be the denominator, and this should be the numerator of the variable. So we're getting the derivative of 4x raised to 3/4, right? So the derivative of x raised to 3/4 is, multiply this exponent to the coefficient 1. So 1 times the 3/4 is just 3/4, right? So 3/4, that's 3/4. 3/4 over 3/4 x, copy the variable x, 3, then subtract 1 from 3/4, the exponent 3/4. Then you get 3/4 x, then 3/4 minus 1 is negative 1/4, right? Then you can write that into this way, in this form. You can write that as 3/4 square root, fourth root rather, fourth root of x raised to negative 1. Or if you want to multiply that, you can also write that this way. 3 times 3 multiplied to fourth root of x raised to negative 1 is just 3 fourth root of x raised to negative 1 all over 4. You could have that as your final answer. Or if your answer is just this way, that's alright. And this, if your answer is just this way, that's also perfectly fine. Alright, so that's how you use power rule, the derivative power rule, right? So you can rewind the video if you are confused in some examples and how in the process. Okay, next we have the fourth one, the constant multiple rule. It's the same concept with the third one, the power rule, because if you have a constant, you just multiplied the exponent of the variable, the function, to its constant, then get the, for example, this way. If you have a 5x cube, if you are getting the derivative of 5x cube, you just need to multiply it 3. Right, so this is your constant, 5 is your constant, and x cube is your function. So this is your constant and this is your function, f of x. Then you just need, you have two options. You can, solution 1, you can separate 5, get 5, the constant, outside of the derivative, then get the derivative of x cube. Now using the power rule, the derivative of x cube is just multiplying the 3 to the coefficient 1. So 3 times 1 is 3. Then subtract 1 from the exponent 3, so that becomes 2. Then multiply 5 times 3 is 15. Then just copy 15x squared. That's the answer. Or you can just simply multiply this 3 and 5, that becomes 15. Then subtract 1 from the exponent of the variable. So copy the variable first. The first thing we did is multiply 3, multiply this exponent to the constant 5. So 3 times 5 becomes 15, right? 15. Then copy the variable x, then subtract 1 from here, subtract 1 from 3. Therefore we get 15x raised to 2 or squared? The answer is the derivative of 5x cubed is 15x squared. Right? So another example. What is the derivative of 9 raised to x? We know that the exponent of 1 is 1. That the exponent of x is 1. So 1 times negative 1, negative 9 is just negative 9. Right? Then the derivative, then subtract 1 from subtract 1 from 1, the exponent, then that gives us negative 9. That gives us negative 9 x to 0. And what is x raised to 0? Any real number multiplied to 0. Any real number raised to 0 is equal to 1. Right? So any real number raised to 0 is equal to 1. Therefore, x raised to 0 is 1. So you can replace it as x raised to 0 is equal to 1. So 9 times negative 9 times 1 is just negative 9. So that's the answer. Right? So that's the answer. Negative 9. That's the derivative of negative 9x. Now you may find it a pattern because that's really the derivative way. If you have only one exponent or the exponent of your variable, single variable is 1, and the derivative of that, if you have any constant multiplied to the if you have a constant here, then multiplied to a variable with the highest exponent of 1, then the derivative of that function, including the constant, is just the constant. Okay? So, for example, another example of applying the constant multiple rule. Just multiply the 3. What is the derivative of pi x cubed? Just multiply 3 to the pi. Pi, we know that that is a constant because that has a value of approximately 3.14. So 3 multiplied to pi is equal to 3 pi, right? Then subtract 1 from 3, that gives us 3 pi x squared, right? So 3 pi x squared. That's the derivative of pi x cubed, right? Now another example. The derivative of 6 multiplied to the cube root of x squared. First thing to do is rewrite this one. Rewrite this function. This is our constant, this is our function. So rewrite first the function into exponential form. Okay, so we are getting the derivative of 6 multiplied. So if we write into exponential form, that will become x raised to 2/3. Okay, x raised to 2/3. Now, what is the derivative of 6x raised to 2/3? Now you just have to multiply 2/3 to the 6. Okay, so you multiply the numerator, and rather multiply the exponent to the constant. So 2/3 multiplied to 6 multiplied by 6 is 6 times 2 is 12, right? 6 times 2 is 12 divided by 3 becomes 4. So becomes 4. Copy the variable x, then subtract 1 from 2/3. That will give you 4x raised to negative 1/3. Right? If you want to write it this way, yes, we can do that. If your answer is just like this, that's perfectly fine. So if we can rewrite this way, that's okay. We can rewrite as 4 the cube root of x raised to negative 1. We could have that as our final answer, and that's okay. If this is your final answer, that's okay. That is also correct. Right? So that's the fourth rule of the differentiation. Now let's move to the last two of the basic rules. We have the fifth one, the fifth rule, and the sixth rule, which is the sum and the difference rule. Now, if it is sum, if we are having the positive sign or the positive symbol, the plus sign, if it is a difference rule when we are seeing or if we are operating under negative sign. Okay, for example, in this example, we can say that it is a positive symbol, therefore we're using sum rule. So the derivative of 2x plus 5, all we need to do, according to the sum and difference rule, if you have two functions added together and if you are getting the derivative of both functions, you just need to get the derivative of each function, then add their derivatives, right? So first get the derivative of f of x, then get the derivative of the g of x, or the second function, then add them together. So the derivative, we have the first function f of x here, the 2x, and the second function is the g, the 5 rather. So this is our f and this is our g function. Now get first the derivative of the first function. So equals derivative of 2x added by the derivative of the second function, which is 5. So we know that the derivative of 2x, or the derivative of 2x, is just multiply the exponent to the coefficient 1, so coefficient 2 rather. So 1 times 2 is just 2. Then we know that x raised to 1 minus 1 is becomes x raised to 0. So x raised to 0 is just simply 1, so that's 1. Plus the derivative of a constant is 0. Therefore 2 times 1 is 2, plus 0 is just 2. Therefore this is the derivative of 2x plus 5. Right? Now the example, the derivative of x squared minus 16. Now we are operating under negative sign, so therefore we are using difference rule. And difference rule, similar to the sum rule, we are just getting first the derivative of the first function, then get the derivative of the second function. This is our first function f, and the second function g is 16. Get the derivative of x squared first, then get the derivative of the 16, then subtract them. Right? So we'll do that. So derivative of x squared minus the derivative of 16. Right? So the derivative of x squared is just 2x by power rule. 2 times 1 is 2. Subtract 1 from the exponent. Copy the variable first, then subtract 1 from 2. The exponent 2 becomes 1. So that just becomes 2x raised to 1, or just 2x. Minus the derivative of any constant is 0. Therefore, the final answer is just 2x. 2x minus 0 is 2x. Therefore, the final answer is 2x. Derivative of x squared minus 16 is equals to 2x. Right? So that's the final answer. Now, another example. We have this trinomial expression. We have 1, 2, 3, 3 terms, trinomial expression. Now, the derivative of that function, of course, we are operating under difference and sum. So we are applying both difference and sum rules. So we'll do that. So we'll separate them each term. So we're getting the derivative of 16x squared subtracted by the derivative of p5x, then added by the derivative of that last term, which is 1 over x. Now we can write 1 over x into exponential form, which is x raised to negative 1. Right? So the derivative of 16x squared is just multiply the exponent to the coefficient 16. So 2 times 16 is 32. Then copy the variable x, subtract 1 from the variable. So 2 minus 1 is just 1, or just simply x raised to 1, or just simply x, so 32x. The derivative of 16x squared is 32x, right? The derivative of 5x is just simply multiply, we can do that like the constant multiple rule. So 5, then get the derivative of x. We know that the derivative of x is 1, so therefore we can just write as 1. Then added by the derivative of x raised to negative 1. We know that by power rule, we just need to multiply the exponent to the coefficient. So negative 1 times the coefficient 1 is negative 1. Then copy the variable, subtract 1 from the exponent. Then we get this one. We got this term, or this expression. Now simplifying 32x, just write it down. 32x, 5 times 1 is just 5, plus so positive times negative becomes negative, so negative x, because we don't need to write the coefficient once, because in algebra we can just write x. We can understand that it has one coefficient. Okay, so negative 1 and negative 1 is negative 2. We can have that as final answer, or we can write that as this final answer, or we can just write this as or is equal to 32x minus 5 minus 1 over x squared, We can have this as our final answer, or this one is also correct. If your answer is this, if your final answer is this, that's also correct. Right? So that's how we operate under the sum and difference rule of differentiation. So try these examples from items 1 through 6. And item 6, you just need to use the f prime of t to get the derivative. So f prime of t, then just differentiate each term, just like we do from the last example. We did in the last example, but we are operating under the variable of t. So with respect to the variable t, so we are the derivative of t2 is just 2t. Derivative of 2t is just 2. Derivative of a constant is 0. So the answer here is just derivative of the f prime of t is equal to 2t plus 2. Right? So answer the items 1 through 5. You can try that on your own. If you have any questions, you can message me privately, or you can just comment on this video. Okay? Okay. Have a great day.